Good morning, everybody.
Morning, sir.
Morning, sir.
Morning, sir.
Good morning, sir.
Everybody can see the screen, all right?
Yes, sir.
Morning, sir.
Good morning. All right. So the session is being recorded. And so all the persons who are not here today will be able to watch the video. All right. So this is our first session online. And the plan and the idea is to do this every week, as backup work or practice. And also just to go over some of the stuff that we do in the week. And especially the assignments that I give you. Because in tomorrow's class and Monday's class, we're moving on to new material. All right. So this is basically a solid part of the program, a very important part of the program. It's a pity that everybody cannot attend, but then hopefully they all be able to watch the video. All right. So as you can see on the screen, this is the question that we did in our class activity the other day. And I just want to take the chance now to work through it. Kind of explain the solution. All right, so let me another paper and then track back. Just keep it mic muted when you're not. All right. All right, guys. So this was the question that we did in the last class, this quadratics functions question. So this was presented by quadratic. We know it's a quadratic because the highest power of the square of the variable term is a square. The highest power of the variable term is a square. And this is basically a typical quadratic in the standard form. All right. And the first part is asking us to write this expression in this form. In other words, they want us to complete the square. All right. But generally speaking, for our class, we tend not to work with this form because, as I said, CXC tends to change the way they present this in questions all the time. So because CXC is constantly changing the way they present that expression, I prefer to write this expression in another form, which is a bracket x minus .
Sir.
Your screen is going. Oh, sir, screen gone, bro. Without we, sir, gone.
Can you hear me again? Can you see the screen again?
Yes, sir. Yes, sir.
So the internet jumped off a while ago. So I'm actually working with some Wi-Fi. If it goes again, then I'll hotspot it. All right. If it goes again, then I'll hotspot it and we proceed. So as I was saying, instead of working with this format, I tend to work with this format. It's basically the same format, but in this way, this expression right here, I know what it is. It is the x-value at the turning point because the quadratic function will always have a turning point. So this is the x-value at the turning point, and this is a y-value at the turning point. So this process involves working out what this value is and what this value is. All right, the A is the same value as the A in the standard form, which is the 3. All right. So the primary objective in this method is to find this value and this value. And it's a formula that can be used to find those values. So if I were to start by writing back the expression, which is g of x equals 3x squared minus 8x plus 2. And then we're going to be using g of x equals a bracket x minus xt squared plus yt. Then the xt that is coming here, there's a formula for it. Xt is negative b divided by 2a. Now, where do I get the a and the b from? I get it from the standard form. So in the standard form up here, the a is the coefficient in front the x, which is this value 3. Not the x, the coefficient of the x squared. The coefficient of the x squared is always given the letter a. All right, so in this case, the a is equal to 3. And then the b is the coefficient of the x, which is this number. The number in front, the x, and I have to carry the negative with it, but it's actually a negative 8. So it doesn't matter where it appears in the expression. If it was in front, the number in front of the x is still given the letter b in the formulation method that we're using. So b is equal to negative 8. And then the c, this is a constant term. We're going to actually use that to find yt. So this is given letter c. So the c is equal to that 2. So back to this formula now to calculate the value that is coming here. That becomes equal to minus. Now this minus is this one. Let's put that in a different color to ensure that we see it. Let's put it in purple. So this minus is this one. And then the b now, this b is this b, which is equal to negative 8. So where the b is right here, I have to put a negative 8 there because b is negative 8. So this minus is this one, and then the b is negative 8 from here. All right. And so this minus becomes a plus. I can even bracket this as my b. And I'm dividing that now by 2 times a. That's 2 times the a value is 3. Then this minus becomes a positive 8. Minus is a plus. And this 2 times 3 is a 6. Now, most persons got that in a class. Almost everybody got that in a class. But what a lot of persons did not do is reduce it to lowest terms. Must always simplify. Whenever an expression that can be simplified, a fraction or anything that can be simplified, it is expected that you will simplify it. So this can be divided by 2 to give us 4, and this can be divided by 2 to give us 3. So this reduces to 4 over 3. So 4 over 3 is the value coming right here for the xt. That's the x value at the turning point. All right. Then we need the y value at the turning point, yt. That's this value right here. That value, formula for that value is 4ac minus b squared divided by 4a. And so these are 2 formulae that we must know. This one, we must know it. I'm putting it in a red box. And this one we also must know it. We must know those 2. But I'm going to work it out beside it still. I'm going to put some values in for this. So that becomes equal to 4 times the a. Remember the a is 3 up here. The a is 3. Times the c. The c is 2. Minus, that's this minus that I'm placing here. So again, to highlight that minus, I'm going to put it in a different color. I'm going to put it in purple. This minus is this one. And that minus is not squaring. It's going to come back as a minus. And then now the b, we're squaring the b. But the b is negative 8, you know, so we're squaring negative 8. So we're squaring the negative 8. but this minus is not squaring, so it stays as a minus, divided by 4 times a, and the a again is this 3 up here. So 4 times 3 we have under here. And so this expression now reduces to, let's put it here, yt becomes equal to 4 times 3 is 12, 12 times 2 is 24. This becomes 24. This minus stays minus. I'm going to put it back in purple. And that same purple minus, it stays minus. And then this negative 8 squared coming here, it becomes a 64, because negative 8 squared means negative 8 times negative 8. That becomes 64. So that is 64. And then you're dividing that by this 4 times 3. 4 times 3 under here is 12. So that is a 12. All right. And then now, this then becomes 24 minus 64. That's a negative number. It's negative 40 divided by this 12 right here. And here again, we have an expression that can be simplified. We have an expression that can be simplified. So now it's a matter of simplifying this, because this can be divided by 4, that 40, and this 12 can also be divided by 4. So that simplifies down to negative 10 over 3. 4 into this goes 10 times, and 4 into this is 3 times. All right, so this yt is the value coming here. All right, so now that we have those, we can then write our expression. All right, this expression here becomes equal to, or becomes g of x, becomes equal to the a. The a, remember, is 3 bracket x minus, that's x minus, and the xt is this 4 over 3. 4 over 3. Don't forget to put on this square right here. Don't forget the square. And this plus yt is negative 10 over 3. And so that becomes negative 10 over 3. But this yt is the same as plus yt as we have here. So we can replace it with this negative 10 over 3. And that is the answer for the first part. This is the answer for the first part right here. This thing is the answer for the first part. Any question on that?
Yes, sir.
Everybody
Sir,
okay?
I have a question, sir.
Speak a little louder, sound a little bit low. I don't know if it is my device or what, but it sounds a little bit low.
Sir, I have a question, sir.
Yeah, go ahead.
Question, sir. For the YT formula, sir, the ones having the red box, is that way you would use that formula for everything, or it changes based on the question?
No, it's the same formula. If you're using this method, it's the same formula for YT. Once it's a quadratic that you're writing in a vertex form, it's the same formula that can be used for YT. Now listen, this is not the only method to do this question now, but this is the method that we use in this class, my program. In TSEC, when I do the same topic at AdMaths, I use a different method. But for TSEC, this is the method that I use in my class. And that is the formula that we use to calculate the YT value every time.
All right, sir.
All right. And then the other one up here is the same formula for XT. Now, YT can be found another way to it, but I won't get into showing that other way yet, because you can actually find YT from the XT value. I can just tell you, if I use this negative, this 4 over 3 value right here, and I substitute it in the function for the x here and here, all of this will work out to the same YT value, because YT is the Y value when x equals the XT value. The XT and the YT are the same point. They're coordinates of the turning point. That's what the T stands for, turning point. All right. So YT is the Y value when the X value is XT. All right, where the coordinates of the turning point. All right, so the second part now says we have to state whether g of x has a maximum or minimum. So that is now part 2. All right, let's go back for the blue. So the quadratic function will have a smile shape when the a is positive. So in this case, it is the a that tells us this. The a tells us whether it's a maximum or minimum. So the a value in the standard form, which is this a. So the a is equal to 3, which is a positive value. That's a positive value. When the a is positive, we tend to say the graph feels nice. And so the graph will have a smile shape. When the a is positive, the graph will have a smile shape going like this. And then when the graph smiles like that, if you think of it as coming from left to right along the graph, so like you're going from left to right along the graph this way. So as you're coming down initially, here you're coming down, the y values are coming down. Then the y values get to this lowest y value, and then the y values start to increase again. So when it smiles, it has a minimum value and a minimum points, and that's it. So know that because the a is positive, the graph will have a smile shape, and when it has a smile shape, it has a minimum value. And so that is the answer. It will have a minimum value. So g of x, which is also your y values. This g of x is also your y values. Instead of saying g of x here, the question could have given you instead y. But the g of x values are your y values. All right? That's a different way of expressing the quadratic. All right? So we know that g of x has a minimum value. G of x has a minimum value. That's his answer. That's answer for that one. Then this one says we have to state this maximum or minimum value. So I can cross out the word maximum now, because I know it is a minimum value that it has. So I can cross out this word maximum, because it is a minimum value that it has. Here again, I can cross out the word maximum, because we know it has a minimum value. All right? And they're asking us to state that minimum value. All right? Now that minimum value is the YT value, the Y value at the turning point, right here. The Y value at that point. All right? Now, let me just show you something. I'm just sort of repeating some of what we did in class, but it's a revision session. So this point, this minimum point, will have coordinates xt, yt. The same xt and yt that we calculated up here. Those are the values coming down on the coordinates here. So what happens is that the graph, the y values on the graph, comes down to this minimum value. That's the minimum y value on the graph. So the answer for this question is that y value. It is the y value that can have a minimum or a maximum. X can take any value. You can put any value you want in the function, but the y value will come down to a minimum of that, and then it will go back up. So the minimum value is the yt value at all times. So part 3, the minimum, this means minimum value, is the yt value. And the yt value happens to be negative 10/3. This yt value here. And this is one of the reasons why I teach this topic this way. Because when you do this kind of question, the part 2 and the part 3 and the part 4s of these kinds of questions, generally speaking, tend to be one of these values, either the xt value or the yt value or the combination of the xt and the yt value. Completing the square is really all about analyzing this turning point. That's what completing the square mainly is about, right? It's a property of a quadratic curve of the turning point. Whether it's a smile curve or a throne curve, it has a turning point. In the case of a smile curve, it has a minimum turning point. In the case of a frown curve, it has a maximum turning point. And completing the square really and truly is about, talking about that turning point. And also talking about the axis of symmetry. All right? And you get the minimum value at the turning point if it's a smile curve, and you get the maximum value at the turning point if it is a frown curve. All right? So we know that this is the maximum value, the minimum value, sorry. This is the minimum value. This is the minimum curve. All right? The next part now down here, part 4, is telling us to state the value of x at which g of x is minimum. This is the value of x, this one, same xt value. When the y value is yt, the x value is xt. It's at the same point. So it is when x equals this value that the y value becomes minimum. All right, so the answer is the xt value, the same x value at that same turning point. All right, so part 4, they're asking us for the x value when the function is minimum. So we can say g of x is minimum when is it minimum? When the x value becomes equal to the xt value. And what is the xt value? 4/3. 4/3. So we can say i.e. that is when the x value is 4/3. So this is the value of x that will make the function have a minimum value. And it all happens at that minimum point. It all happens at that minimum point. That's the answer for part 4. And then part 5 now is basically asking us to sketch the graph. We have to show the y-axis intercept. We have to show the turning point. We have to show the axis of symmetry. And then we have to show the position of the roots. All right, so we're going to do a sketch of it now. All right, so let's look at how we analyze and bring down the sketch. What do we do to get the sketch? So I want to see what the information, what do we consider for the sketch? Sketch of this function. Now remember, we have the standard form up here. And the standard form is able to tell us 2 things about the curve. Remember, the g of x is equal to, hold on a second. Hello? Hello? Good afternoon. Yes? I'm in a class right now. Can you wait until after the class? Come back in about 2 hours time, please. 2 hours. 2 hours from now. All right, cool. All right. All right, so the g of x is equal to 3x squared minus 8x plus 2. Now, you really don't need to rewrite this to do this pattern, but I'm just doing it for the purpose of explaining. So this tells us 2 things. This standard form tells us 2 things. What are the 2 things? This a value, a equals 3, it tells us the shape of the graph. And because this is a positive value, we know that the shape of the graph is a smile. A smile. This c value out here in the standard form, the c value, c equals 2. That tells us the y-axis intercept, the y-intercept. Tells us where the graph crosses the y-axis. And it will always cross the y-axis at a point 0, c. In this case, it is 0, 2. Remember now, on the y-axis, the x value is 0. And if the x value is 0, think of it. If you take a value of 0 and you put it in the function here for the x and here for the x, all of this will be gone. Because this will be 0 and this will be 0. And what you'll be left with is the y value equal to 2. And that's why the coordinates of that point is 0, 2 on the y-axis where the x value is 0. So those are the 2 pieces of information that we get from the standard form. So we know that the graph has a smile shape. And when it has a smile shape, it has a minimum value, yes. It has a minimum point, sorry, yes. But then the standard form also tells us where the y-axis intercept is. So that's two pieces of information that we are getting from the standard form. All right. Then now remember we did the vertex form. This is what we call the vertex form or the turning point form. The turning point is also called the vertex. So this form gives us some information about the vertex or the turning point. That's form 2, where we now have g of x equals 3 into x minus, it was 4/3 squared plus, or we can say minus 10/3. All right, now this is in the form x minus xt. So this is x minus xt. So this value is xt, this one. And this, all of this is yt. All of this is yt. All right, so this is your yt. So this form gives you some information about the turning point. So based on this form, the xt is the x value at turning point and the yt is the y value at turning point. And it's a minimum point. So what we know from this standard, from this vertex form or turning point form, is that the minimum point has coordinates xt, yt, where the xt is 4/3 and the yt is negative 10/3. And so this is where the turning point is. So we want to put this information in red together to make a sketch of the graph. And that is sufficient for us to make a sketch of the graph using that information in red. The fact that it smiles, the fact that it crosses the y-axis here, and the fact that it turns at this point down here. That's where it turns. That's where the turning point is, the minimum turning point. All right? So let's put it all together now and do a sketch. All right, so I'm going to put the sketch on the right side of the screen. Let's put it over here. So I'm going to put in my y-axis. I'm going to put in my x-axis. Y-axis, x-axis. This is a sketch. It's not going to be to scale, all right? All right. So we know that it has a smile shape. Let's go for the purpose to sketch it. So we know it has a smile shape. But we can't just draw any random smile anywhere. But we know that it's going to shape like that. So the first question is, where does it turn? It turns at this point. It turns at this point. This is where the graph turns. So the question is, where on this graph would this point be? It turns where the x value at the turning point is positive. And x values are positive to the right of the y-axis. And it turns where the y value at the point is negative. And y values are negative down below the y-axis. So with these two combinations, with positive x and a negative y, we know that the turning point is somewhere down here in this quadrant. That's what we know. We know that it turns somewhere down here. So we can leave that. All right? The next question is, where does the graph cross the y-axis? It crosses the y-axis at this point here, 0, 2. Where would 0, 2 be on this graph over here? Where would it be? Sorry. It has to be somewhere up here where y values are positive. Cannot be down here because down here y values are negative. And it cannot be at this origin because right here, the y value is 0. So it's not there. So we must draw a smile that turns down here and crosses somewhere up here. That's what we need. A smile, it has to be a smile and it must turn down here and it must cross somewhere up here. So I'm going to draw that now let's draw it in red. So when I draw my smile, it must cross somewhere up here and I must turn somewhere down here. So I just need to draw any smile that does that because this is just a sketch. So I'm going to draw it like this. Let's see, it cross up here and it turns down here. Let me take these purple marks off now. That's my sketch. And then once I have my sketch, it's now just a matter of labeling the sketch. So this turning point, and I see in the class, some people put in a turning point here. No, the turning point is the lowest point that the graph came down to. Right? Right down here, the lowest point, that's a turning point. And that point has coordinates xt, yt. So this point is coming right here, xt, yt. So we can put that in 4/3, 4/3, and negative 10/3. This point right here. This point is 4/3, negative 10/3. That's a minimum point. This right is a little bit better. Mute the mic, please. Somebody's mic is open. Pen giving a little bit of problem. I think I need a new pen. That's it. All right. And then this point over here now, this one, it is right here. The y-axis intercept. The graph crosses the y-axis. And so we have to label that one as well. All right. We have to label that one as well. So we're going to label right here as 0, 2. 0, 2. Put it in a bracket like that. So that's the point 0, 2 on the sketch. All right. So far, so good. The question asks us to show the position of the roots, not to calculate the values of the roots. You know. We're going to deal with that in the next class. The roots are located here. Let me use a different color for the roots. The roots are located. The roots are located here and here. These are the two roots. We can call this root number 1. And this one is root number 2. That's where the roots are. But the question also asks for the axis of symmetry. Let's put it on in a different color. Let's put it on maybe in black. Do I have a black here? Black. Let's put it on in black. So the axis of symmetry is a vertical line passing through the turning point here. It's vertical. It's vertical like the y-axis. Hold on, I'm going to change this pen because we'll try a different pen.
Yes, Daddy.
Mute the mic, please. Mute the mic. Mute the mic, please.
Machine's finished.
Mute the mic, please. So this is a turning point, and the axis of symmetry is a vertical line passing through that point. All right, and so it goes like this. That's the axis of symmetry. It must pass through here. All right, and so I can label this vertical line as the axis of symmetry. And the equation of that line is x equals whatever the x value is here, because every point on this line is going to have the same x value, which is 4/3. Because x equals the xt value. That is it. And that basically completed that question. That's the axis of symmetry. Everybody good with that so far? Everybody have a question?
No, sir.
No, sir.
All right, beautiful. So I'm going to do the next question, the second question that I gave in the class. And then my aim is to do the 2 questions that I sent last night in the group. All right, that's the next thing to do. The 2 questions that I sent in the group last night. So let's see. Let me see now. I think it is right here. All right, so this is a question that I gave in the class to do. This was like an extra question that I gave to do. And I want to take the opportunity because I gave 2 additional questions last night, similar to this one. So basically, this is how they are setting a lot of the quadratics questions in recent times. So the 3 questions that I gave you, this one and the 2 last night, they are on exam papers since after 2020. So know that they are very recent questions. This one, as you can see, is 2022. This is January 2022. You can see the date up there. We look at it, you can see the date up in the title there. 2022, January 2022, paper 2 exam. All right, and this is the number 8 question. This is a quadratic question. Okay? Now, let's look at it. It gives us this function, and that's just another way of writing it. F is such that. So instead of putting it like this, they could have written instead, just as they did here. It's the same thing, see? This is the same thing. That's just another way of expressing the same thing. And they could have also used y equals 3 plus 5x minus x squared. It's not complicated. Mute your mic, please. Keep your mic muted if you're not speaking to the class. All right? So all those 3 really is the same thing. The focus at the end of the day is on the expression. Yes. Mute your mic, please. Mute your mic. Look if your mic is open and mute it if it is open. You mean that person not listening, you know? They're not listening. I keep saying mute your mic and the person still talking. They're not listening to the class. They're just there. All right. All right. So as I said, the focus really is on this expression. Now, as soon as you see a quadratic, right, in the standard form right here, you automatically should start deciphering whether it's a smile or a frown from a standard form. Now, remember, this x squared term is right now negative enough. And so you know it's a frown. It's going to have a frown shape. And then this is a C value. So even though it appears first, this is actually a C value. C is equal to 3. So it means that the crosses y-axis at 0, 3. So you know that before you start to do anything. All right? You know that before you start to do anything. But this is a question where you're not asked to do a sketch. You're actually asked to plot points, and also determine some stuff from a graph. So actually drawing a graph, not just making a sketch. So you see, they have actually started a graph for us. And they've been doing that in recent times. All right, but the first part here wants us to complete the table. So they want us to fill out these values. So they gave us 4, and they want us to put 4 in there. Now, I want us to start appreciating and understanding something about the quadratic function. The quadratic function is a symmetric function. It is symmetric. It has a line of symmetry. And the symmetry are also seen in the y values. They are seen in the y values because some of the y values are repeated. So for example, you see a 9 here and a 9 here. And what will happen is that from the axis, you see the 9 and the 9 here, I know that the axis is somewhere in between here. The axis of symmetry on the graph can also be drawn on the table. And what will happen is that the values will be the same going this way, they're reducing that way, and the same going that way from the axis. And sometimes you don't need to work out all the values. A lot of the times you don't need to work out all the values. So what I know, for example, is that whatever value is here and here is the same. Because what? They are on either side of the 9. I automatically know that this value is 3. So here's a 3, without working anything, just because of the symmetric nature of the function, So from this value, we're going back to 3. So from here, we're going back to 3. And then I automatically know that this value is here. So I know that this is -3, So without working out anything, I know those. Just that whatever value I get for here, let me look at it, let me show you again. The values are symmetrical, so these 2 are the same. These 2 are the same. These 2 are the same. And these 2 are the same. Why is that? Because these x values have the same interval. It is 1 between them right through. These values are all increasing by 1. Right? So I know that the symmetric nature of the function. So a lot of the time you don't have to work out everything. If you know that, it's only 2 marks for the question, you know. So really and truly, you don't need to work out all the values if you use the symmetric nature of the quadratic function, which also is shown in this in the values. So let me tell you something right off the bat. Let me tell you something right. Listen to me carefully now. 9, this graph has a front shape and will have a maximum value. 9 is not the maximum value on this function. Cannot be the maximum value. Even though it's the largest value we are seeing in the table, it is not the maximum value. The maximum value cannot appear at 2 different points. The maximum value occurs at only 1 point alone. What this is saying, is that on either side of the maximum point, you come down to 9 and you come down to 9. So it means that there's a value higher than 9 between them. So the maximum value is a value higher than 9. The maximum value is a unique value. 1 point only you have that maximum value, which is at the vertex point. But the vertex point is just that it is not shown in the table, because the table is showing whole number x values. See? But the vertex point in this case is not a whole number x value. It is actually between these 2 values, perfectly between those 2 values. This red line here represents where the axis of symmetry would be, right between the 2 and the 3. And the 2 takes us up to 9, the 3 takes us up to 9, and then the values start decreasing back down this way and decreasing back down that way. So these are the 2 values closest to in terms of what is in the table, closest to the maximum value. But the maximum value is a value that is on the axis of symmetry, and the axis of symmetry would basically be on this red line that I've drawn, this red line, right between the 2 and the 3. So like you're taking the average between the 2 and the 3. That is 2.5. So the axis of symmetry is where x is equal to 2.5. I don't need to calculate it. We can calculate it from this to, and if you calculate xt from that, you're going to get 2.5. And let me show you. All right? I'm not showing you, just for showing your sake. If I calculate xt using this, I'm going to get 2.5 or 5 over 2. See, look. Xt is minus b over 2a. What is the b in this? The b is this 5. That's a 5. That's minus 5. That's minus 5 over 2 times a. What is the a? The a is a number in front of the x squared. There's no number in there, so it's actually a -1. See, that is the a value. So I'm putting -1 right here. My a value is -1. So I'm putting a -1 right here. This is -5 divided by -2 becomes a positive 5 over 2. They cancel. 5 over 2 is 2.5. So you say xt is 2.5. But because they give me the table and I can see the symmetry in the values, I can determine that my axis of symmetry is right between the 2 and the 3, and the average between 2 and 3 is 2.5. So I could know that it is 2.5 without doing this calculation. Then the maximum point, so this is xt really, this is x value at the turning point, Remember, the xt is on the axis of symmetry. So if I want the y value at the turning point, so we are saying not 9. We are saying 9 is not the maximum value. See there, this is what I was saying. 9, so you cannot say 9. 9 is not the maximum value because it appeared at 2 points. The maximum value appears at the vertex point only. The quadratic graph only has 1 vertex point with 1 maximum x value and 1 value of x at that point. That is the xt and the yt value. All right? I'm just trying to emphasize so we can understand this thing. Not just know how to do it, but actually understand it. So if I were to calculate the YT value right here, I can do it using the formula again, you know. But I can also plug the 2.5 in the function and get the YT value. I can do it two ways, right? I'm not filling these out yet, I'm going to do this soon, but I'm just taking the moment to show you that I don't want anybody to run off to think that 9 is a maximum value. And the question tend to test your knowledge of that. So right at this point, what will be the y value be when x is 2.5? You can just plug it in here. So the y value, which is the y value turning point, is going to be 3 plus 5 times 2.5 minus 2.5 squared. Right? If I plug the 2.5 here for the x and 2.5 here for this x, that's what I'm going to get. All right? And if you work this out, I'm not going to work it out now, but if you work it out, I think it comes to 9.25. So the YT value becomes 9.25 if you work it out. If I work out the YT value using the other way, 4AC minus B squared over 4A, you're going to get the same thing. YT equals 4AC minus B squared over 4A using the formula method to get YT. Then we would get 4 times the A value is -1 from the coefficient of x squared is -1 times C, the C value is 3 minus the B is 5 and you're squaring that 5 divided by 4 times A, the A is -1 again. If we work this down, this is going to become -12 because it is 4 times -1 is -4, -4 times 3 is -12. And then this becomes minus same way. This minus stays a minus right here. Minus, and then the 5 squared is 25. You're dividing that now by this negative, that -4. So this actually becomes, what is this now? -37 over -4. They cancel each other and get 37 over 4. And if we divide 37 by 4, we're going to get 9 remainder 1 over 4, which is the same as 9.25, 9.25. So that proves it. That's doing it another way. But you don't have to do this because you have the graph, you have the table, and you can actually see it. So this would be the quick way to do it this time to find the YT value. All right. So the maximum value would actually be this. You see, it is higher than 9. That's the highest Y value on the graph. And it appears at the axis of symmetry at the vertex point. All right. Well, let's get to the question now. Then. Let's get to the question. So let's do it in blue. So let's say I want to work out this point, the value for here. As I said, I know it's 3, because it's symmetrical to that. So I know it's 3. Well, let's prove that it is 3. So at x equals 0, well, it's obvious at x equals 0. If you plug in 0 here for the x and 0 here for that one, these two will be gone. And the y is going to be equal to this 3 right here. So the y is equal to 3 when x equals 0. All right? So right here, when x equals 0, the y value is 3. Can't bother waste time and work out two easy things. So at this point, the x value is 3. And I know that basically this is 3 and this is 3. But this one go out towards the -3. I know that this one going to go to -3 as well. I don't have to work it out, I just know. And whatever value this is, as I said, this is going to be the same value. But the values are symmetrical. It's like how the curve is symmetrical, the values are symmetrical. Well, let me write them out still, just for the purpose of proving what I'm saying. All right. So this value now is where x equals 1 right here. So to find what that value is, I need to plug 1 into the function. All right. So let's do it over here. So we have that one. Now when x equals 1, I'm going to plug the 1 into the function here for the x, there and there. So I'm gonna get the y coming out to be 3 plus 5 times 1, 5 times 1 minus 1 squared. This becomes 8, and this 1 squared is 1. So it becomes 8 minus 1, which is 7. So it means that 7 is the y value when x value is 1. So that point, that value is 7. So automatically, this value is 7. Because when I come to the left of 9, I get to 7. So when I go to the right of this line on the other side of the axis, it must come to 7 as well. So this value, without working it out, I know that this value here has to be a 7. But if you're not sure, I can work it out and show you, just for illustration purposes. All right, I'm going to work out for the 4 and show you, but you don't need to work it out. So when x equals 4, it's only 2 marks for the question, guys. So we don't need to work out everything. Use your knowledge of the symmetric nature of the function. All right, when x equals 4, y becomes equal to 3 plus 5 times 4 minus 4 squared. That becomes 7 as well. Because this is 20, and 3 make 23. So you get 23 minus, this becomes 16. 23 minus 16 is 7. Right? So that is it. This is 7, which proves it. That is 7. So right here is a 7, but we should have known that since this is a 7, that is a 7. And as I said, since to the left of this tree is -3, to the right of this tree is also -3. So I know that the last value out here is the same, -3. Right here is -3. I wouldn't have to work it out, but out of the symmetry of the function. All right, but I'm going to work it out still with the 6 and show you. So I'm going to do it down here. So when x equals 6, the y becomes 3 plus 5 times 6 minus 6 squared. Now this is 3, and this is 30. 30 and 3 is 33. Minus 6 squared is 36. So 33 minus 36 is -3, which is what we know we should have right here. But as I said, we did not have to work it out. But that is it. We have completed the table. But okay with that so far?
Yes, sir.
Yes, sir.
Yes, sir.
You understand my explanation about 9 not being the maximum
Yes,
value?
sir.
Yes, sir.
Cannot be the maximum value because the maximum value occurs at only 1 point, and the 9 is at 2 different points. The quadratic graph, the maximum value can only be at 1 point only, right at the vertex point. So 9 cannot be the maximum. A lot of people put 9 as a maximum. The maximum or minimum cannot be any value that occurs at 2 points, because the maximum occurs at the vertex point. The vertex point is a unique point. It is the only point with those coordinates. It's the only point that has that maximum value. The maximum value or the minimum value, it occurs at one single vertex point, the turning point. So 9 cannot be the maximum value because 9 is at 2 points. The maximum value must therefore be higher than 9. Must be higher than 9. In this case, it is 9.25. All right. So let's go on to the next part now, which is to basically plot the graph. All right. So looking at this graph, see where the 2 9s are here. So there are 2 9s. So x value of 2 give us 9, y value of 2 give us 9. So you see this red line on the table that I drew in the table right here. If I were to draw the corresponding, this red line represents the axis of symmetry, you know, in the table, you know. But to draw it on the graph, you're going for it is exactly between those 2 points. And so it is this line here that divides between those 2 points. This is the axis of symmetry of this graph, you know. This is going to be the axis of symmetry for this quadratic graph. Right here. See, it passed right between the 2 and the 3 again, which is right here is 2.5, x equals 2.5. And all the values are the same distance on either side. So for example, see this point over here, this distance, there's a corresponding point, the same distance this way. So look at this now. This is how many units to the right? 1, 2, 3, 4, 5 units to the right of this line. So there's a point, 5 units on this side as well. 1, 2, 3, 4, 5, which is right here. This is a 0, 3 point that we have. See there? The 0, 3 point. See there, so? So in a lot of cases, we don't even have a draw. We don't even plot everything. Because we can use the symmetric nature of the graph. I want us to understand that. And don't just work the question. We must do the question with a level of understanding of it. The more you know, the better. Similarly, this point down here, whatever the distance is to this axis, there's a point on the other side of it, the same distance. And you can actually count it off, and then I can find it on the table and show you. 1, 2, 3, 4, 5, 6, 7. 7 is the distance to the unit, to the axis of symmetry. So there's a point like this on the other side of the axis, 7 units from the axis. 1, 2, 3, 4, 5, 6, 7 right here. There's a point right there. What point is that? 6, -3. So this point is a 6, -3 point that we have over here. See it here, so? 6, -3. 6 is the x value. -3 is the y value. So you see, I'm even putting in some of the points without depending on the table, just using the symmetric nature of the function, the quadratic function, because the points are the equidistant on either side of the axis of symmetry. The axis of symmetry divides the graph into 2 equal halves. So those are 2 points. Then there's another point now that we have to work out two of them. That's this one and this one, the 1, 7 and the 4, 7. They sort of correspond to each other in terms of the distance on the axis. 1, 7 and 4, 7. So 1, 7 first. So 1, so 1 here up to 7. It's a 7 here, so this is 1, 7 right here. So we're talking about this intersection here. That is 1, 7. This point. This point is how many units from this axis? So call it 1, 2, 3 units to the axis. So the corresponding point for that is 3 units on the other side of the axis. 1, 2, 3 right here. This is a 4, 7 point, you know. I can bet you. See there? See the 4 there? It is a 4, 7 point. All right? So there are some things that you can do quickly when you understand certain properties of the function. Now, a lot of persons when they draw this, right? Because the vertex point was not given on the table. So this is where some students will get maximum marks and some students will not get maximum marks, you know. Because really and truly, only the students who fully understand the quadratic will know, right, that there's a point above 9. The turning point is actually above 9. The turning point is actually on the axis of symmetry. So there's a point on this axis. There's a point on the graph on this axis that we need to identify. It is the point that we worked out, the xt, yt point, which works out to be 2.5, 9.25. So we have to put this point on the graph, even though the question did not put it for us in the table. So this is how CXC tests your knowledge. Because a lot of persons draw this graph and come straight across here. No, the quadratic graph is a curve. There's no straight line segment on it. It's a curve. So you cannot draw the graph like this. Come on. Like that. And then you go straight across here and then come back down like that. No, you must know that the graph goes above these 2 points and come back down. And because you're on graph paper, you want to get it accurately. You want to actually get 9.25. So let's go and work out where 9.25 would be. Let's work it out. Where would 9.25 be? Let's look at the scale, everything important. Mathematics is the most exact science. So right here is 9. This is 9. And this is 10. So it means that 9.5 is right between the 9 and the 10, right? So 9.5 is like right here. 9.5. Then halfway between 9.5 and 9 is 9.25. So it means that 9.25 is like you're coming right halfway between here and here. So you can maybe put it about here. So this must be 9.25. So you need to draw the graph so that they come up to that level. 9.25, somewhere up here. So we'll come across, this will be my axis of symmetry. My vertex point right here. That's my maximum point. So you have to make sure that the graph goes up to there. Let's draw the graph in blue now. You have to make sure that it goes up here. You cannot go straight across here with it. No, you have to know that this point exists. That is a vertex. This is this point up here. This point is that. 2.5, 9.25. You have to include this point on your graph. All right, and then we can draw the graph to the point. Another thing, I see some person drawing a graph and they're skipping the points. No, you have to make sure that you pass through the points. You must pass through the points. You cannot have the points there on the graph and you're drawing the graph beside them. Like you're drawing it beside. No, everything important. Make sure you must pass through the points that you know on the graph. Once you know that the point is on the graph, you make sure you pass through them. All right, the best way you can. See there? All right, up here again, I'm coming over, pass through that one. Pass through that one. Pass through that one. And don't use any rule line or that curve. All right, so if it look like you're drawing straight line segments, you go over, do it over. It's a curve. Everything important. See there? Do it properly. So that you don't give CXC any reason to take off any marks. Just always remember this. Mathematics is the most exact science. You have to be exact. You're always trying to be exact. The only time you don't need to be exact is when they tell you that you don't need to be exact. Once you don't tell anything, your aim is to be exact. It is the most exact science. So you cannot have a point on a graph and you're drawing the graph. And the graph is supposed to pass through the point. And you don't draw it through the point. You must draw it through the point. If you go in the exam room, and you're drawing this graph, and you go and draw this part of it, like so, I make it pass. Let's say you go and draw it like this in the exam room. I make it pass over here, so and don't pass through this one. And then you go down. See, it's going to take off mark for you not allowing it to pass through that point. You cannot take these things for granted. Everything is important. The point is there, and the graph passes through the point for sure. You must make sure that it passes through. You must show it passing through. All right? Everybody good so far?
Yes, sir.
Yes, sir.
Yes,
Now
sir.
listen to me now. Listen to me now. I'm just talking and saying it from now, and I say it at the end. But just in case I forget. It's when I'm finished, all the questions I'm doing today, especially if you did not get it right, you have to redo it. But out of foolishness, all the questions that I'm doing today, because I'm doing questions that I sent last night in the group. If you even made one little teeny mistake, I want you to redo it. We are trying to master these things. When you master these things, you get everything right without having to think. That's always the aim in math. You want to do your exam questions and just do it without thinking. That's the level you want to reach. When you master it, you will do it without thinking. I tell people all the time that you are able to do an exam without thinking. That is the level that we are trying to get at. That's what our aim is. To be able to do questions without having to think, especially questions that are of the same format that CXC has set before. Any question that they set that is laid out similar or in the same way that they have set before, we are to be able to do those questions without thinking. We just need to focus and concentrate and don't make mistakes, but we know what to do. And we understand it to a level such that if they make minor changes to the question, we still know what to do because we understand it inside out, from the bottom up, from the top down, from left to right. We understand it in all angles. The way to get to that level is to practice, practice, practice. And if you do a question and you make a mistake on it, you are redoing that question. Leave no stones unturned. Leave no stones unturned. That is how we operate in this program. That is how we guarantee success in this program. We leave no stones unturned. Don't make a mistake and say, okay, I understand my mistake. No, all right. Redo the question from scratch. Redo the question. Once you make a mistake on it, do it over. Make it lodge in your brain. The right thing to do. All right, enough of that. Let's continue. This part down here now says, write down the axis of symmetry. You don't need to do any work. This is only 1 mark for it. So you're expected to know that the axis of symmetry is right between these 2 points on the graph and right between these 2 values on the table, because you have the 9 and the 9 here. It's on this red line, which is right in between the 2 and the 3. So it has to be x equals 2.5. All right. So I hope our understanding of this thing is growing. It is progress before perfection. Progress before perfection. We're not going to master it just yet, but we have to put in the work to master it. So it's x equals 2.5. If you want to write 5 over 2, same thing. If you want to write 2.5, same thing. Right? But that is it. X equals 2.5. It's the axis of symmetry. State the maximum value. We worked it out. We had to work it out because it was not given in the table. Trust me. All the people who get grade 3 in the exam room, them write 9. People who get grade 4 and who get grade 2, them write 9 and lose that mark. We want this 1 mark. Every mark important. We want it. So we have to know that it is 9.25. That is the maximum value on this function. That's the highest y value that the graph went up to. The highest y value that the graph went up to right here. It is not 9. The maximum value cannot be at 2 different points. The maximum value appears or it occurs at 1 single point only, which is called a vertex point. That's where it occurs. The maximum value occurs at the vertex. It's 1 unique maximum value at 1 point. In the case of a smile graph, same concept, just that it's now at the minimum point. So the minimum value occurs at 1 single minimum point. It's on the line of symmetry. It's right at the vertex, right at the turning point. We need to know this thing inside out. We're moving on to new stuff. From tomorrow. our vertex business. Inside out. All right, so that is the answer about that one. But we want the 1 mark. Don't go put in on 9. You put 9 on, I'm gonna get the 1 mark. So remember, I tell you, the maximum value cannot happen at two different points. Minimum value cannot happen at 2 different points. The graph only has 1 vertex. 1 vertex it has. So once you see a value at 2 different points, that's not the vertex. And a quadratic graph I'm talking about. All right. So I didn't ask you to do this part. All right. So we didn't even know that part. This is for when we do coordinate geometry. So we didn't even know that part. All right. Body good? Body okay?
Yes, sir.
Body want any additional explanation? Okay. Remember enough to tell me yes or no. I assume says yes or no.
Sir.
Yes.
Sir, can you repeat how you got the 2.5 the 2.5 again?
2.5. All right.
Yes.
So you can actually see it on the graph. So the graph, there's the values here. So these are the x values going up here. Trust me, it is far more simple than you're maybe thinking. It is just like obvious. So since this has a 9 here and a 9 here, you know that this is not the axis of symmetry. This is not the axis, this is not the vertex, I mean. That's not the vertex point. So like remember, we know it's a front shape graph, right? Because the A is negative, right? The x squared term is negative. So you know the graph going up, the y value is going up. And you can actually see it in the value. See it here? The y value is going up from -3 to 3 to 7 to 9. Then it's to a 9 again. So you know, say go past 9, reach a vertex and start come back down and reach 9 again. So you therefore know that the maximum value is more than 9. It go above 9 and come back down to 9. So remember this, -3 up to 3 up to 7 up to 9. Then it go above 9 and then come back down to 9. All right? And the graph is symmetrical. So just as I look at these values now, these y values to the right of this line for 9, 7, 3, -3. Then to the left of this for 9, 7, 3, -3. So you therefore know that the axis of symmetry is between these two in terms of your y values. And so it is between these two in terms of the x values. These are your x values. It is between the axis of symmetry is halfway between the 2 and the 3. Why? Because the 2 is what gave you a value of 9. And the 3 is what gives you a value of 9. And we know that what happens is that the values are the same distance from the axis of symmetry. The points on the graph are the same distance from the axis of symmetry. So the axis of symmetry must be between 2 and 3, exactly between 2 and 3. The value that is exactly between 2 and 3 is 2.5. If you're reasoning it out that way. But remember, when you have the values in a quadratic function, you can actually calculate it using this formula right here. Minus b over 2a. So that's another way to do it right here. But when you have the table like this, you don't need to do the calculation because you can look at it and see that it has to be on this line, which is exactly between the 2 and the 3. The value that is exactly same distance between 2 and 3 is 2.5. Understand it any better based on that explanation?
Yes, sir.
All right. Anybody else? All right then. So let's see if we can find the next one, the one that I gave you yesterday. Let's see if we can find. I don't remember which paper it's on, but let me see if I can find it. I don't remember which. Oh, I sent you the paper last night in the group. So I sent you the whole paper. Right. So I decided that instead of just sending you the question, I'm going to send the entire paper. All right. So that if you want, you can look at other questions on the paper, start to get a feel for the papers. All right. So one was actually 2023, June 2023. So you see, I'm really giving you recent exam papers. So June 2023. So these are my June papers in here. And I want 2023, which is this one. All right, let's go.
Sir,
Yes?
sir, quadratics come from paper on your paper.
Yes. On paper one, multiple choice. Yeah, man. You're gonna see quadratics question on paper one as well. Quadratics is a big topic. And there are other things in quadratics that we have to know to do, which we're continue in quadratics this week and next week. All right. All right. So a similar question here. Here's a similar question on a different paper. This is 2023. So they give you the table. All right. They give us this table. It was the function. We look at it right away. You see that there? It's negative x squared. So you know that it frowns. And when it frowns, it has a maximum value. Remember, the maximum occurs just at the vertex alone. All right. So we're going to see some of the values and see if we can figure out where the vertex is, right? We also know that this is the y-axis intercept right here. All right, which is at this point. Because at this point, the x value is 0. This is on the y-axis. So this corresponds to here. That is 0.07. All right, we're going to have to put in a couple other values and see if we can pick up the symmetry of it and show you. And then I think they want us to draw the graph down here again. Well, we have to draw the entire thing. Then I'm plotting in the points for us on this one. And then they want us to write down the coordinates of the maximum or minimum. We know it's a maximum, so we can actually cross out the word minimum. We know it's a maximum because the square term is negative. Square term is negative, and so we know that it froze and it has a maximum. All right, so this question is similar. All right, I sent this one last night in the group. All right, so let's go. So let's put in some of the values. So, as I'm putting in the values, I'm searching for the symmetry. I'm searching to find the symmetry right away of the values. So maybe I can there are some values that I don't need to calculate. I don't need to calculate all of them. I don't need to calculate all of them. Maybe I calculate 2 and can figure out the other 2 from the symmetry. So let's say I want to put in this one first, the -3. I'm going to plug the -3 inside the x for the x in there. All right, so let's do it down here. So x equals -3. The y is going to be negative, and say square the -3. So watch me now, carefully. So this negative, I'm putting it first. The negative in front of the x squared, I'm putting it first, negative. Then I'm squaring the -3 as the x. So I'm squaring now -3. Plus, again, the x is -3 right here. So I'm adding a -3. I'm breaking it up for you. Plus 7. That's what I'm working on. So this inside here becomes a 9 then. That becomes a 9. But this negative comes back as a negative. It's not changing. So I put back this negative first because this don't square. Right? But then this -3 square will come up 9. So this all works out to be -9 right here. And then this plus -3 is the same as -3. And then I'm adding this 7. That works out to be what? -5. Looks like -5. And that's -12 and 7 is -5. This is -5. -5. So I'm good now, you know. I can start putting some values now. I can actually fill out the rest of it now. Because all these values are in the same interval, the x values. Look, you have to make sure, you know. The x values are all in the same interval, they're all going up by 1. Right? So we're on the symmetry. We can look for the symmetry of the graph. So watch this now. Let me shift this down a bit. I don't have to work out everything, all right? Because I know that the values are symmetrical. I can find out where the axis is by observation. So this -5 corresponds to this -5. So it means that this one is going to place a 1 right here. So this value is going to be a 1. All right? And then this 5 is going to be the same 5 right here. So that's going to be a 5. Then this 7 is going to give me a 7 right here. I don't have to work out nothing else because the function is symmetrical. But I'm going to still work it out just to prove it to you now. So I'm going to leave them there and work them out and show you. All right? I'm going to work them out and show you. All right? just to prove it. Hold on, let me just send a message for this call. Hold on a second. Just send a message for this call. Somebody was calling me. Let me just send a message. Just give me a second, please. All right. So I'm going to prove this. Mute the mic, please. Mute the mic. Remember, I know, these I just put them in based on the symmetry of the function, right? But I'm going to calculate them and show you. Because once I pick up these two are equal, then I do that. These two equal, and these two equal. And then this is my line of symmetry right here. Right? Because the values now are the same on either side of this line. So my line of symmetry, let me put it in for you. It's right between the 0 and the 1. My axis of symmetry is on this line. So my xt value is actually halfway between 0 and 1, which is 0.5. So my xt value, which is the value at the turning point, is 0.5. It's actually 0.5. I know that this becomes my axis. On the graph, my axis on this line, 0.5. All right. If you calculate xt using a formula, I can show you, just to show you, just for the illustration purposes, I can do it up here and say xt is minus b over 2a, which becomes minus. In this function, the b is 1 because the coefficient of the x is 1 right here. So the b is 1, right? So I get minus 1 over 2 times a. The a is a negative 1. The coefficient of this x squared is a negative 1. When you see a negative in front here, it's a negative 1. So I'm putting negative 1 here. So these two negatives cancel. I'm going to put a half. And half is same as 0.5. So you see, my xt value is 0.5 or half. But I could tell from the table without having to do this calculation because I understand the symmetry of the graph. The values are symmetrical about that vertical line. All right? Representing how the graph will go this way. Y values. All right. So let's continue. Let me just work these out and just prove it still. Just for didn't have to work them out, but I'm going to just work them out to prove it, right? So when x equals what? Negative 1 right here. Y becomes equal to minus negative 1 squared plus negative 1 plus 7. This becomes minus 1. So remember now, this negative 1 squared becomes a positive 1, but this minus is not changing. So it's become a negative 1. Then this plus minus 1 becomes a negative 1 again. And then I'm adding 7 plus 7. So these two add up to negative 2. Negative 2 plus 7, same as 7 minus 2 is 5. So you see, it proves it's 5 right here. The 5 that I have right here. Then I'm going to work now for this one. For this value, which is when x equals 1 right here. X equals 1. So when x equals 1, y equals minus again, that's this minus. Then I'm going to put the 1 squared for the x right here, 1 squared. And I got plus 1, that's plus x, which means plus 1, plus 7 equals. This becomes a negative 1 because the 1 squared, so I get negative 1 plus back this one plus 7. These two equals 0. 0 plus 7 is 7. So it works out to be 7. Same 7 that I have right here. And then now, even though I know that this has to be 1 because of the symmetry of that one over there, I can still work out with x equals 3. Right? So if x equals 3, then y equals minus 3 squared plus 3 plus 7. That's what I get when I plug 3 inside the function. Minus 3 squared plus 3 plus 7. When I put 3 in this function, that's what I get. This works out to be what? This become -9. Remember, this negative not squaring, you know, you want to squaring this 3 squared. So you get the -9 plus 3 plus 7. So this 3 and this 7 is 10. 10 minus 9 is 1. 10 minus 9 is 1. So this works out to be 1, which is the same one that I have there. So that proves the table basically. Raw class. Yeah. All right. All right. So that proves the value. But I'm telling you, I did not have to work out these after I did this one and saw the symmetry with that. And I just came inwards towards the axis and make the values equal. And you can do that once the x values up here are in the same interval, the same unit between them. You can do that. Everybody good so far? Everybody okay?
Yes, sir.
Yes, sir.
All right. So now it's a matter of plotting those points. All right. So because I didn't start any points first on the graph, I'm going to have to plot all of them. So I must write them out, right? I must write them out and copy it on the next page. So one point is -3, 5, -3, -5, then -2, 1. That's this one, -2, 1. And then next one is -1, 5. And then 0, 7. And 1, 7. And 2, 5. I'll put a 1, 7 here. 2, 5. 2, 5. 3, 1. And 4, -5. All right, so I'm just going to copy these over onto the next page so I can have them right in front of me. Put on the graph. All right. All right, let me just see if I can put them up here. Let's put them up here. All right. So the first point we need is -3, -5. So -3 here as an x value. So -5 here. So this is where we're going. -3, -5. All right. So see it here. -3, -5. This point right here. The next point is -2, 1. -2, 1. So -2 up 1. Talking about right here. -2, 1 is right here. The next one is -1, 5. -1, -1 up to 5. Talking about this point right here. -1, 5. Next point is 0, 7. 0, 7 is right here on the y-axis. So remember in this question, 7 cannot be the maximum, right? 7 cannot be the maximum, but 7 is here and 7 is here. So let's make a note of that. 7 cannot be the maximum. 7 is not the maximum value. But the maximum value can only appear at one point, and it appears right on this line where x equals 0.5. So you can actually work it out by plugging the near 0.5 in this function. Let's just work it out from that. All right, so 7 is not the maximum. All right, so we're gonna say it is maximum. Y is maximum when the x is equal to 0.5. Therefore, yt, that's a yt now. Maximum value is yt is equal to, we're gonna plug the 0.5 in this now, this function. So we're gonna get negative 0.5 squared plus 0.5 plus 7. And if we work that out, this is 0.25. The square is going to get 0.25. So 0.5 minus 0.25 is 0.25, and you're adding 7, so getting 7.25. So the maximum value is actually 7.25. So the maximum point is 0.5, that's the xt value on this axis, 0.5 and 7.25. So 7.25 is the maximum value. So this is where the maximum point is. So we need to put this on the graph as well, even though they did not give us in the table. All right, 0.5, 7.25. All right, so 0.5. So this is 0.25. So we'll put the axis of symmetry in red. But this is 0 and this is 1. So this line is 0.5. This line. So let's put it in. This line. The axis is on this line. I know that we have the axis, you know. We can actually put in back the other values on this side corresponding to these, you know. We don't have to go back to the table, you know. You can actually know that, for example, there has to be a point same distance from the axis from here. So there has to be a point here, same distance. But the red line is the axis of symmetry, is a point there. This point is what? 1, 2, 3 to that axis of symmetry. So 1, 2, 3. There's a point here on the graph. Which point is that? This point is the point 2, 5. 2, 5 is this one. We can find it in one of the values. See, there is it. 2, 5. See there, 2, 5. Right there. That's the one, 2, 5. So I don't have to do any more. I can just sketch it symmetry. Look at this one. 1, 2, 3, 4, 5 to the axis. 5 on the other side of the axis. 1, 2, 3, 4, 5. Over here. 1, 2, 3, 4, 5. Right here. That's 3, 1. So 3, 1 is a point on the graph as well. Where is it? Where is it? See it here? 3, 1. 3, 1. See it here on the table? 3, 1. That's how easy this topic is. So that's a point on the graph as well, using the symmetric nature of the graph. And then now, this point down here, we can extend this axis all the way down. And then this graph, this point is 1, 2, 3, 4, 5, 6, 7 to the axis. I'm gonna go 7 on the other side. 1, 2, 3, 4, 5, 6, 7. Right out here. Is it at that other point? That coordinate is what? That is 4, -5. So this point is 4, -5. Let's confirm that that's a point that we had as well. 4, -5. Where is it? See there? 4, -5 right here. Look at the table. This one out here. 4, -5. So you see, once you have some of them, you don't have to do the rest. And then again, let's put in this point. 0.5, 7.25 for the vertex point. But you cannot draw the graph and come straight across here. That will be wrong. You have to make sure that the graph continues on this curve and turn right on the vertex, on the axis of symmetry, I should say. All right, so we need 7.25. Let's estimate it again. You see that's a similar thing that we did. So this is 7, and this is 8. So right about here will be 7.5. Halfway. So halfway between here and here now is 7.25. So we're talking about maybe around here. Let me take this off so it becomes a little clearer. All right? So halfway between here and here. About here, so. So when I come and put it, on the axis right here. So that's our vertex point. May that be the vertex point at 7.25. That's a vertex point. Remember, this is a point as well, our axis intercept. All right, so basically that's the graph. I want to draw through those points now. All right, so start up here like that. Coming all the way down here. I'll do the same thing on the other side. The curve. It's called a quadratic curve. As a parabolic shape. Parabolic shape between it as a vertex point and an axis of symmetry. That's a sketch. That's it. As this question now is asking us to write down the coordinates Coordinates mean you have to give the x value and the y value. But we're talking about the maximum point. That is xt, yt. So putting the xt value here and the yt value there. At the vertex, this is 0.5, 7.25, not 7. 7 cannot be the maximum, but 7 is a y value at 2 different points, here and here. So 7 cannot be the maximum. The maximum occurs at one single point only. At that one single vertex point, the graph has only one axis of symmetry, and the vertex is on that point. That finishes that question. But okay? Any questions? Oh, the only say right on axis of symmetry. Sorry, I said we're to do D as well. Right on axis of symmetry. X equals half. X equals half or 0.5. That red vertical line. That red line, this one. This is axis of symmetry. Corresponding in the table to here. X equals 0.5. So this is the axis of symmetry. X equals 0.5. The vertical line passing through 0.5 on the x-axis. This is 0, this is 1. 0.5 is between them. That finishes this question now. Very good. So remember, a number of you did it last night and didn't get it good enough, but not perfect. I want you all to go and redo it. Go and redo the question for me, please. All right, so we have about 15 minutes to finish off about 2 hours, right? It actually started a little bit after 11. So if we do one more question, that will just about take us to 2 hours. I don't like to go past 2 hours on a Saturday. I don't want to be a session that is nice and short, nice and spicy. We must get some quality work in. That is the aim. Everybody can hear me still? Everybody good?
Yes, sir.
Yes, sir.
All right, good. All right, so remember now, guys, I want you all to redo the questions and send them to me. Send them in the group. I want to see the read-on questions coming in the group. So if you know you did it and you made a mistake, you never get it right, send it in the group. Send it to me. So, sir, this is the read-on one. This is the read. Send it, let me see it. Send it to me. Flood me with them. Flood me with them. I want to see everybody working. I want to see everybody putting in the work. That is how we get the results. More maths equals better maths every time. More maths equals better maths every time. The more we do, the better. The more we do, the better. All right? So we need to do more. So redo these questions. So it's to be easy for you. And I tell you to go and do a question from scratch. You know? And if you want me to send you a different question, tell me. But for now, I'm happy for you to just redo these 4 questions. Classwork, the one that I gave you, this one, and the one that I'm going to do next. I'm satisfied with those for now. And if you clean up them one day, and you say, sir, send on another one. But that's all right. And just send on another one. Because more maths equals better maths. Every time. All right, let's see, you know. Boom, bang, boom, bang. All right, hold on. So the next one was on July 2021. So you see, that's how they're setting the questions these days. So let's just go through this one. Okay, maybe move up, maybe move through this one a little bit more quickly. Because basically more of the same. All right, basically more of the same, Let's look at this one now. And those question 8 again, I think. All right, might have been a smile this time. I don't remember. Let's see. Let us see what is what. All these questions and these people are going to do them before the examiner. More than once. All these questions that we're doing. We're going to do them more than one time. All right, so this was it. So this one, they just gave us the table. And all the values were completed in the table. So we're not asked to complete the table. Just to draw the graph and maybe write down the what. This is the minimum. See, the square term is positive, so when it smiles, that's a minimum. So right off the bat, guys, look at this. See a negative 1 and negative 4? Negative 4 is not the minimum value. Somebody unmute the mic and tell me why is it not the minimum value? Why is negative 4 not the minimum value? Why you can't say the minimum value is negative 4? Somebody tell me why, quick.
Can't be in two places at once.
Can't be in two places at once, sir.
And beyond 2 points. The minimum value appears at only 1 point. So negative 4 cannot be the minimum. So you know the minimum value is actually on the line between them. It's on this line between them. And what value appears between negative 1 and 0? Like you average these two. That's negative 0.5. So the minimum value is where x equal negative 0.5. And so to find the minimum value, we'll just take the negative 0.5 and plug it into the function. And that is how we can find the minimum value. One way to do it as well, you know, so just calculate the YT value. You know, because you have the standard form. You have this. So you can also just calculate the YT value using 4AC minus B squared over 4A. You can do it that way too. But I'm doing it this way over here because I want you to understand it to a level. We don't go calculating stuff when we don't need to, because this is enough information for us to know that the minimum point is at the point where x equals 0.5, because the axis is on that line based on these values. Notice the y values are symmetrical about this red line that I've drawn. So that red line is where the axis is, which is right between the 0 and the negative 1. And so we average those to get the xt. If you want to calculate the xt, you're going to get the same 0.5. The xt would be minus b over 2a. If you want to calculate it, it's going to give you the same negative 0.5. I'm not going to do it. I'm going to leave it for you to do. Do the mathematics multiple ways to get the full understanding. When you do the same, when you can find something and work out something multiple ways because of your level of understanding, right? Then that is when we're ready. That is when we're approaching mastery. We want to master this thing. We want to master it. We want to understand it so good that any way CXC set it, we're still gonna get it right. All right, so we know that the axis is on that point. That's xt. That's x value at the turning point, and that's the axis of symmetry as well. X equal 0.5. Well, this one says we have to write down the maximum or minimum. So we know it's a minimum. So we're gonna cross out this word maximum. We know it's a minimum, right? And basically, it is when x equals. It is when x equal negative 0.5. So this question kind of unfair one kind of way. I tell you, say if you calculate it, I tell you to write it down, but you really have to work it out. Okay, you can't just look and see it in the table. It's not like it is in the table. So that's why a lot of people just put -4, which is wrong. Right? A lot of people just put -4, but we know. You never know before, you know today, that the minimum point can't happen. Or the minimum value can't happen at 2 different points. All right? So when I work it out from the x equal negative thing, or you want to calculate xt, let's do it 2 ways then. More math equals better math. So when I calculate this way, the y value turning point is the minimum value, which works out to be negative 0.5 squared plus 0.5 minus 4. Minus 4. So this works out to be negative 0.25 plus 0.5 minus 4. All right, so this looks like negative 4.25. That's right. Oh, this doesn't look right. So, oh, this is supposed to be a minus 0.5, not a plus. My mistake. Because it's plus x. It's plus x, you know, but x is, the x that we're using is negative 0.5. All right, so this is actually a mistake here. It's supposed to be negative. So this is negative 0.5 and negative 0.5. So all that works out. Oh, this will become a positive 0.5. Another mistake here. So wow. So we square this, it becomes a positive 0.25. 0.25. Okay, ready now. So that's all we get. Negative 4.25. Negative 4.25. Or to be 9.25. Negative 9.25. Or it could be negative 37/4. All right, negative 37/4. But let's work it out using xt now, yt. So yt is 4ac minus b squared over 4a. That will be 4 times the a. The a in this expression is 1. The a in this expression is 1. The c is this negative 4 right here. Minus the b is also 1. So minus in 1 squared divided by 4a. The a is 1. This works out to what now? This is negative 16. Negative 60. What did I say? I wrote down something wrong a while ago. Negative 16 and negative 1 give me negative 17. Negative 17/4. I think I wrote down the wrong thing here a while ago, but no problem. We have to try it now. That's 4.25. I wrote 9.25. I don't know. I don't remember what I wrote. That's negative 4.25. I feel like I wrote something wrong over here a while ago. But what you see on the screen is the correct thing now. 17/4. All right. So when they calculate, when they're using the value that they deduce, that is it. But it's not negative 4. All right. So this is the answer. Whether you do it that way or you do it this way. Negative 4.25. If you believe this one, same thing. All right. Then it says use a ruler, draw the axis of symmetry. Draw the axis of symmetry. So I want us to draw the graph first, plot the points and draw the graph, and then draw the axis of symmetry. Axis of symmetry is this, minus a half. All right, so it's a matter of plotting the points. Oh, so they give us some of the points. They didn't give us the other. So let's put in the axis first, and then maybe we can deduce the rest. Negative 0.5. Negative 0.5. So negative 1, this is 0. So negative 0.5 is this line. So this becomes the axis of symmetry. Which is x equal negative 0.5. We have 1, 2, 3, 4 values. So I think we have the 4 values on the left of it. All right. 1, 2, 3, 4 values over here. So let's put in the others on the right. I know that the values are symmetrical, so I don't have to waste time, right? Let's put them on the right. So 1 unit from this. So we know that 1 is right here. That's 0, negative 4. Let's see if that is there. 0, negative 4. Just to make sure. See there, 0, negative 4. Then 1, negative 2. Corresponding to this one. So this is how many? 1, 2, 3 from the line. And go 1, 2, 3 on the side. 1, 2, 3. See there? Right here. That's the next one. And this one is 1, 2, 3, 4, 5 from the line of symmetry, axis of symmetry. 1, 2, 3, 4, 5. Right here. That is 2. That's right. 1, 2, 3, 4, 5. 2, 2 is a point. 2, 2. Yes, see there. 2, 2 is a point. Good. All right. So we're making sure everything is consistent. Everything is correct. Everything is exact. And let's continue the axis of symmetry up here. All the way up. I have this point out here as well. Now this is 1, 2, 3, 4, 5, 6, 7 from the line. 1, 2, 3, 4, 5, 6, 7 right here. That point is 3, 8. 3, 8. 8 there, 3, 8. Let's check if 3, 8 is a point. 3, 8. Let's just check if 3, 8 is a point. There you go. 3, 8. So you can actually draw it just using the symmetric nature. of it. You have to plot everything and go back and forth to the table. That's how I want you all to know it. And remember now, the axis is, the vertex is at 0.5. This is the x-y vertex, and this is the y-y vertex. So the vertex point, or the minimum point, is negative 0.5 on the axis of symmetry, negative 4.25. Right, not negative 4, negative 4.25. So let's look at it now. So same sort of thing. Let's put it in blue. So this is negative 4 and this is negative 5. So negative 4.5 will be here. Negative 4.5. So negative 4.25 is about here. Negative 4.25. So talking about this point right here. The graph must come down to this point. That's the axis. That's a vertex point. That is a vertex. Or it's a minimum point. All right, so the graph must pass through that. So let's draw it in blue now. Let's draw it in blue. So I'm going to come down. Bam, 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 bam. Come down and turn at the vertex and go back up. Let's go again. Bam. Bam, 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 bam. Turn at the vertex and go right back up. Like that. I'm drawing it with my finger and then it's have to bear with me. Important thing is that you don't come across here with a straight line. Don't do that. You have to make sure that you come down to the vertex, to continue the graph down to this vertex point and then go back up. All right. You have to make sure you do that. Okay, sure. That is a sketch. That is a sketch. And axis of symmetry is that vertical red line. Anything else what to do? Nope. And that is it. All right, guys. Very good.
Yes, sir.
Okay.
Yes,
Sure.
sir.
Yes, sir.
All right. So what you gonna do for me now, please? Somebody tell me what we're gonna do now.
Yeah. Read it and send it.
So again, say it again.
Get it wrong, read it, send it to you.
Beautiful. Yeah, and if you get it right, you can redo it still now, but especially if you get it wrong, you must redo it. So remember, I'm not asking you to go and do a new question. What I'm gonna do, I'm gonna send you the link to the video, and so that you can use the video now to look back over any little thing. So you want to look back at something that I've said, you have the video to look at. I'm gonna send you the link to the video. All right, so you have it to just use to guide you and help you along. We're using up everything available to us now, using all the tools available to us. So the session is recorded. I'm gonna just send the link to the group right afterwards. So you can just go while you're doing it over, you have something to check. If there's something that I said, and you say, oh, sorry, say this again, you can go back and just listen it again and so on. All right, because moving on to new stuff come tomorrow. All of these things will be revised again multiple times, you know, so not to worry, you know. We're gonna do 1 million of these questions, even these particular questions. We're gonna redo them again at some point, multiple times. You're gonna have to do all these papers under exam conditions at some point before the exam. All right, so you're gonna see these things again numerous times. All right, because more maths equals better maths every time. All right, guys. So that is it for today. I'll see you all tomorrow and Monday. Looking forward to it. All right, it's gonna be fun. It's gonna be fun, fun, fun. Tomorrow and Monday this week is gonna be fun. All right, see you then. All right, bye everybody.
Bye, sir.
Bye, sir.
Bye, sir.
Okay, bye.